It is one of the hottest topics among the scientific community. How big is our universe? As we gaze up at the endless expanse of the night sky, we are reminded of our own insignificance in the grand scheme of things. The countless stars twinkling above us serve as a silent reminder that our tiny home planet is just a minuscule speck in the vastness of the universe. A mere glance at the celestial canvas above us is enough to grasp the incomprehensible enormity of the universe, a vastness that stretches far beyond the limits of our imagination. It is a mystery that may never be fully unraveled, a puzzle that could potentially remain unsolved forever. Despite this vastness, the question still toys with human intrigue. If you've ever wondered, where does the universe end? You're not alone. Great physicists, such as the late Stephen Hawking, and many other theoretical scientists have been pondering this question for decades. In 1917, Albert Einstein made a groundbreaking prediction about the expansion of the universe, a theory he initially had doubts about until he saw evidence from Hubble and Humason. His general theory of relativity posited that the very fabric of space was expanding, causing galaxies to move further apart. When a photon is emitted from a distant star, it travels through an ever-expanding universe, adding to the already huge distance it must cover to reach us. But just how vast has the cosmos grown since the Big Bang? Recent precise measurements from the Hubble Space Telescope and other instruments estimate that the universe is 13.8 billion years old. Within this time, a beam of light could have traveled 13.8 billion light years, or approximately 1.3 quadrillion kilometers. However, taking the expansion of the universe into account, the most distant galaxies observed by the Hubble are actually now 46.5 billion light-years away from us in each direction. That is 93 billion light-years from each other. So, is this the true size of the universe? To accurately determine the size of any object, it is crucial to first understand its shape. The actual shape of the universe has been a topic of discussion and debate among researchers, and there still isn't a satisfactory answer. Remember that Einstein's theory of relativity says that space and time can bend and morph. Space could be one of a variety of different shapes. It's hard to imagine this in the 3 dimensions that we know space really is, so let's substitute a 2-dimensional analogy. In flat regions of space-time, objects traveling along parallel paths stay along parallel paths. In positively curved regions of space-time, parallel paths converge, and in negatively curved regions of space-time, parallel paths diverge. But what about space as a whole? If space is positively curved everywhere, then the universe would be shaped like a giant sphere, where if you kept on walking, you could, in principle, end up back where you started. If space is flat everywhere, its shape could be simple, extending out straight to infinity. And if space is negatively curved everywhere, things would fly instead of falling. So, which is it? One method of determining the curvature of an object is by assessing the angles within its triangles. If the object is flat, the sum of the angles will equate to 180 degrees. Conversely, if the object is curved, the angles will result in a sum greater or lesser than 180 degrees, depending upon the nature of its curvature. Cosmologists using the Planck Observatory have done the equivalent of measuring our universe's triangles by looking at a picture of the early universe and studying the spatial relationship between different points on that picture. So what did Planck and other experiments find? It turns out that measurements show the universe to pretty much be flat, within 0.4% margin of error. So can we conclude that space is flat and infinite? Physics is an experimental science. When we say that the Earth is flat, what we mean is that the measurement is consistent with being flat. But that also means that the measurement is consistent with a tiny bit of curvature. For example, if we're at the beach on the ocean and look at the horizon, it surely looks flat. But, in spite of the claims of some people, the Earth most certainly isn't flat. It's a sphere. So we have to keep this in mind. What appears to be flat can indeed be curved. And when we measure Earth, we can only say that it appears to be flat. That is true for space as well. Space appears to be flat. But what if space is an extremely large sphere, so big that it looks flat, just like the Earth can look flat? Well, in that case, space is not infinite. It has a finite size. During a careful analysis, using the maximum possible curvature allowed by the best measurements, astronomers found that the universe can be no smaller than 250 times bigger than the visible universe. That's 93 billion light-years times 250, which is 23 trillion light-years. Put it another way, the whole universe is to the observable universe as the Sun is to the United States. So does that mean the universe has an edge? And if there is an edge, what lies beyond it? The universe, as far as astronomers can tell currently, may or may not have an edge. Instead, there exists only the edge of the observable universe. Like a spotlight shining from wherever you stand, illuminating the edge of what you can see but nothing beyond. An immense area covering 93 billion light-years of consistently expanding space that we are capable of observing from Earth using powerful telescopes. When we gaze at a distant galaxy millions of light-years away inside this circle, we are observing it as it was millions of years ago, not as it exists in the present time. The further we look, the further back in time we can see, until finally we encounter the earliest light that occurred just a few 100,000 years after the Big Bang. This is not a physical edge, but instead the afterglow of the Big Bang, known as the cosmic microwave background, the farthest point in the universe that we can observe from Earth. And yes, the universe could always indeed be infinite in size. In that case, the calculation of its size becomes pointless. By definition, there can be no shape assigned to an infinite object, as it lacks any boundary points that could be used in mathematical calculations. This infinite expanse would come as a sense of majesty and beauty that is beyond comprehension. Imagine the endless stars and galaxies, each one unique and full of its own secrets and wonders, stretching out into infinity. And the fact that the universe also continues to expand, creating new space and new possibilities for the future, only adds to the magic of its boundless nature. Whether you're an astronomer, a philosopher, or someone simply who appreciates the beauty of the cosmos, the infinite universe theory is an awe-inspiring wonder that will continue to captivate the imagination for generations to come. And it's a reminder that amidst the bustling chaos of our everyday lives, we are but a tiny speck in the vast expanse of the universe. So the next time you look up at the night sky and see the stars twinkling in the distance, take a moment to remember that you are but a tiny, fleeting spark in the grand cosmic drama, and embrace the infinite mystery and beauty of the universe. For it is in that infinite space that we truly find our place. Let's embark on a wondrous trip into the abyss and actually realize the true scale of the universe, starting from Earth. As we begin to zoom out, the Odyssey commences with our birthplace, the Earth, a planet that stands apart, being the only celestial body in the known cosmos that harbors life. Millions of diverse species flourish on its ever-changing terrain. However, none have altered its aspect as significantly as the human race. From this height, the impact of human civilization is palpable, with our man-made structures, highways, and agricultural fields likely to persist as evidence of our existence for centuries, if not millennia. Yet, as we soar higher, every aspect of who we are and what we have built begins to fade. From this vantage point, it becomes challenging to discern that we ever existed. Our entire history is rooted in this solitary blue sphere, a place where billions have lived, died, and where countless more will come into being. This is the world where it all started for us, the cradle of humanity. But now, we must leave all of this behind and travel further than any human being has ever traveled before, as our destination is quite literally the edge of the universe. Our first stop is the Moon, our closest celestial neighbor, and the only other celestial body where humans have set foot. Subsequently, we cross the orbits of other planets as we head towards the boundless void of interstellar space. Our Sun, the star that nourishes our seas, stirs our atmosphere, and provides energy to the growing plants that produce oxygen for life on Earth, becomes just one of billions. Many of the stars that dot our night sky can now be seen in their vivid glory, untainted by the Earth's atmosphere, like bright, colorful dots on a black canvas. This is just a tiny fraction of the Milky Way galaxy, where some of the stars possess exoplanets, some of which may possess the suitable conditions for life as we know it. Nonetheless, we cannot pause to explore these alien worlds, as we have a long journey ahead, and the Milky Way is incomprehensibly vast. Clouds of gas and dust, together with hundreds of billions of stars, planets, and moons, extend across an area that spans 100,000 light years, and concealed within its brilliant bulge lies a monster, a supermassive black hole. From this location, we can grasp the sheer magnitude of the galaxy that we call home, which, despite its enormity, is just a droplet in the ocean of galaxies that pervade the observable universe. Each of these shining points represents another galaxy, brimming with clouds of gas and dust and billions of celestial bodies. Like the Milky Way, which is now just a faint speck in the distance, most of these galaxies harbor a supermassive black hole at their center, some of which are even merging in a cosmic dance of gravitational interaction. This awe-inspiring view reveals that the universe is not evenly distributed, with large, empty voids between dense clusters, connected in a magnificent cosmic web. This is just a tiny glimpse of the observable universe, a single page in a 13.8 billion year tome spread before us. The journey shows the incredible scale of the universe and the relative insignificance of our planet in the grand scheme of things. At this point, we might try to question ourselves, our existence. The truth is that our knowledge is limited, and essentially, we are cognizant of nothing. The delusion of having all the answers restricts our ability to embrace and contemplate the infinite possibilities of the universe. As we exist on this tiny speck of dirt floating aimlessly in the vast emptiness of space, it is remarkable that we have the capability to see as deeply and widely into the cosmos as we have. Nonetheless, our understanding remains minimal, and the reasons behind the occurrences in the universe are often beyond the grasp of our limited minds. So the next time something happens that doesn't go your way, just go with it. Just go with the flow. There's no point in resisting the universe. Life is not about having all the answers, but rather embracing and relishing the moments as they come. Our existence is not limited to that of an individual, but rather we are an integral part of the universe, a focal point where the cosmos is becoming aware of itself. From our limited perspective at this moment, being in our heads, we feel quite separate from the universe. But think about it this way. Every atom that comprises our being once originated from a star. And over billions of years, the universe evolved and changed to bring us into existence. That's how you were made, literally from star stuff. It took billions of years for the universe to evolve and change and create us. We're tiny, but we're also exceptionally special, as is everything in the cosmos. The universe is intelligent. It's not just a bunch of dumb matter floating around colliding haphazardly. One universal intelligence or one consciousness is what's guiding this whole thing, including you. We just feel like separate cells because that's how our limited minds work. As Neil deGrasse Tyson put it, and I quote, "We're all connected to each other biologically, to the Earth chemically, to the rest of the universe atomically. Not only are we in the universe is in us. As we are the universe, it is our responsibility to treat each other with love, respect, and dignity. Our survival as a species and a planet depends on our unity, and I believe that we have the potential to persevere. Until then, the question of what lies beyond our observable universe can wait and remain one of the greatest mysteries of all time. Even with all the knowledge that we have gathered so far, we are still just scratching the surface of understanding the universe. And as we come to the end of our journey, exploring the biggest secrets of the cosmos, it's hard not to feel a sense of existential crisis. But this realization should not bring us down. Instead, it should inspire us to continue searching for answers and expanding our understanding of the universe. After all, the pursuit of knowledge is what makes us human. And our quest to uncover the secrets of the universe is a testament to our insatiable curiosity. So as we close this chapter, let us not forget the infinite possibilities and wonders that lie beyond our grasp, waiting to be discovered. The universe is a never-ending story, and we are merely a small part of it. Let us embrace the unknown. Let us never stop searching and exploring, for the biggest secrets of the universe are still waiting to be revealed.